let me just take the opportunity to introduce you to our lesson on simultaneous equations. And in this lesson, we'll be looking at more advanced questions as it relates to simultaneous equations. Now, here to be specific, we have one linear and one nonlinear. Now, what does a linear equation mean? A linear equation is an equation that the highest power of the variable is 1. And if you notice in equation 2, we have y is equal to 7x plus 5. That's this equation number 2, and let me just state it right there. So in equation 2, I have a linear equation where the highest power of x is 1. So that's what we mean by a linear equation. Now we have another equation in equation number 1 that I'm stating here. In equation 1, equation 1 is a nonlinear equation, and if you notice, to be specific, it's a quadratic equation because the highest power of the variable, the letter in x, is 2, and any equation in which the highest power of the variable is 2, it's called a quadratic. Now I have in equation 1 y is equal to 2x squared plus 1, and in equation 2 I have y is equal to 7x plus 5. Now by intuition, as it relates to even the whole concept of substitution, we have stated that in an equation, basically you want both sides of the equation to be of the same value. And if you notice in equation 1, we have y is equal to some expression in x, okay, and in equation 2 we also have y is equal to some expression in x rather. So I could say then y must be equal to y, because if this equation is y equals something and that equation is y equals something, then my left hand side of the equation, if I should equate both, and my right hand side would have the same value. So with no further ado, I will just go ahead, since I have an equation in y as the subject, and one also here as y, and the other in equation 2 as y as the subject. I'm going to say let's equate equations 1 and equations 2. Okay, now if I should equate that, then I'm just going to take what is y in the first equation, and I'm going to say 2x squared plus 1, and that is y on this side, and I'm going to say that is equal to y, which is 7x plus 5. Now basically, when I look at this equation, I realize I have a quadratic equation because the highest power of the variable in this equation is 2. And you would have learned, and if you're not sure, you could always go back and visit those lessons on quadratics, okay, wherein as we stated that when working with quadratics, you should take everything to the left hand side and 0 must remain on the right hand side. So I'm just going to transpose and bring everything on this side. So I would have a 2x squared, and when I look here, I see I have a 7x. Now to bring over this 7x, I would have to subtract 7x from both sides of my equation. Okay, now here in bringing over that 7x, I would have minus 7x plus my 1, and that is equal to this 7x, and I would have to subtract 7x. Okay, that's the reason why okay, now I would have my plus 5. So I would know that a positive 7x would cancel out with a negative 7x. So really what I'm left with is 2x squared minus 7x plus 1. Oops, sorry, I should have a plus 1 here. Good. And that is equal to, I would have a 5 left over there. All right. Now, if you notice, this is a positive 5. So to bring over the 5, I would have to subtract 5 from both sides. So I would have to say 2x squared minus 7x plus 1, and if I'm subtracting 5 from both sides, I would have minus 5 is equal to 5 minus 5. Now I know that I would be left with here 2x squared minus 7x, and this would give me a negative 4. Okay, and that is equal to 5 minus 5 will cancel out, so I'm left with 0. Now when you look at this, you see that we have a quadratic equation in its general form. Now we would have note in the previous playlist on solving quadratics, different ways of solving quadratic equations. We can solve a quadratic by factorization, or we can solve a quadratic by using the quadratic formula. Okay, so when you reach here, it doesn't matter how you solve this. Okay, if it's not specified, you could use the quadratic formula or by factorization. I chose to go factorization because it's much quicker. Now when factorizing, you would know that a times c, and if you're not clear on factorization on what I'm doing now, you could always go back and check the playlist on solving quadratics by factorization. So basically I'm going to take a, which is 2, and I'm going to take c, which is negative 4, and I would get a negative 8. Now basically what I must do, I must now find factors of negative 8. When I add them, factors of negative 8, when I add them, I must get a negative 7, and when I multiply them, I must get negative 8. By intuition, you would have now known that 8 times 1 would give me a positive 8. So obviously I need to change the sign on one of these, and when I look at my b is negative 7. So since b is negative 7, my larger factor should carry the sign that b carries. So now I know now that when I multiply negative 8 times positive 1, I would get a negative 8, which is that. Okay, that's what I'm looking for. And when I add negative 8 plus 1, I would get a negative 7, which is my b here, what I'm looking for, this b there. So I have my two factors here. I'm going to use negative 8 times 1. However, now basically I'm just going to expand this, so I'm going to have my 2x squared, and I'm going to use my negative 8x plus x minus 4, and that must be equal to 0. Now I'm going to just say what is common to 2x squared and minus 8x, and I have a 2x. So that's 2x, so I'm taking out 2x. 2x into 2x squared will leave me with a x, and I have a positive into a negative will give me a positive, and 2 into 8 will give me 4, and x will cancel x, so that's good. Now I'm taking down this sign that is here and place it right there, and I'm going to say now that what is common to x and negative 4, so I would have a 1 that's common. So all I'm doing is saying 1 into positive x will give me back x, and 1 into negative 4 will give me back a negative 4. Now if you look carefully, you would have noted that I have the same thing inside my bracket, so we're good, and I must equate that to 0. So all I'm doing now is to combine what's on the outside of the brackets, which is 2x plus 1. Okay, this 2x here and this one here I'm combining, and I'm going to put that in a bracket, and since I have the same thing inside the brackets, I'm just going to rewrite one of that. Okay guys, it's really that easy, and equate that to 0 because I'm working with an equation, so I must remember to equate that to 0. Now it's pretty straightforward from here. Just let me clear this a bit so that we can have the space to work with. Just let me get that out of the way quickly. Oops, okay, that's good. Now all I'm going to do, since I have factorized my quadratic, these are my factors. My factors are basically 2x plus 1. So I have a 2x. Okay, let me just split the screen. So I have a 2x plus 1, and that is equal to 0. Or I have x minus 4, and x minus 4 equal to 0. Now basically what I did was to just take out my two factors, take out this factor 2x plus 1 and equate it to 0, and I took out my x minus 4 also and equate it to 0, because when working with a quadratic we know that we should always have two solutions for x. Okay, so now basically I'm just going to just solve for x. So I have a 1 being added to 2x, so that simply means I must do the opposite of addition to move this one, which is subtraction. So I'm going to have a 2x plus 1 minus 1, and that is equal to 0 minus 1. Now I know that a positive will cancel out with a negative 1, so I'm left with 2x is equal to negative 1. 0 minus 1, negative 1. 2 is multiplying x, so I must do the opposite of multiplication, which is division. So that 2 will cancel that 2, and I must divide this side by 2. Therefore, x is equal to negative a half. Okay, so that's one solution for x. Now I need to find the next solution for x. So over here now I have a 4 being subtracted from x, so I'm going to say x minus 4, and I have to do the opposite of subtraction, which is addition. Plus 4 is equal to 0 plus 4. Now what I did to this side, I must do to that side, so that's why I add 4 over there. So I'm left with x here, because a positive 4 will cancel out with a negative 4. So I have a x is equal to 4. Now from here in I have two solutions for x. So by intuition it would suggest that if I have two solutions for x, I must have two solutions for y also. So now I need to find my two solutions for y. So all I'm going to do, I'm just going to take each solution for x and substitute it in any one of these equations and solve for y, the two corresponding y values. Okay, so now I'm saying substitute x is equal to negative a half into, and I'm going to choose the simplest equation. So I'm going to choose equation 2. You could choose any one, it doesn't matter which. Now I have equation 2 says y is equal to 7x plus 5. So I'm going to just remove x and put negative a half, okay, times negative a half plus 5. Now basically from here in, that's y, and 7 times negative a half will give me a negative 7 over 2. Plus 5. Now we have fractions to calculate. When we're calculating fractions, we usually find our LCD. Now our LCD is 2. So what I have here is basically 2 into 2 goes once. 1 times 7 is minus 7. And 1 into 2 goes 2 times, and 2 5s, I have a 10. So y, my y value is really 10 minus 7. And 10 minus 7, this implies then that y, let me change this a bit, that y is equal to, we would have a 3 over 2. Now I have found my corresponding y value when x is equal to negative a half. Now I need to find my corresponding y value when x is equal to 4. So let me change my color. So here now I'm just going to do the same thing. I'm going to say substitute x is equal to 4. So this value I'm taking now, x value, x is equal to 4 into, and I'm going to do it in the same equation, into equation 2. Now equation 2 states also that y is equal to 7x plus 5. So y, I'm just going to remove x. 7 times 4 plus 5. So y would be equal to 7 fours. I would have a 28 plus 5. So y would be equal to 33. So that's it. I have found my two x values, and now I've found my two y values. So therefore it's now time to make our statements. So I can say therefore when x is equal to negative a half, and these statements are very important, y is equal to 3 over 2. And in the second instance, we now should state that when x is equal to 4, y is equal to 30, sorry, let me just change that, y is equal to 33. Now if you notice, we have found the values of x and the values of y. And to be very important, it's the corresponding x value to the corresponding y value. And here it's also the same thing. Now what you could do, you could always plug it in back in both equations to double check yourself if you're correct. Wherever x is, you put in the value of x, and wherever y is, you put in the value of y, just to check if you are fine. Okay, that's it. It's really that easy. Let me just put this. These would be our answers. Okay, bye bye.